In this video, I'm going to talk about exact differential equations. Sometimes we run into differential equations of this form. P of xy plus q of xy times dy over dx equal to 0. If you look at this differential equation, you kind of could think about it this way, sort of slightly modified way or slightly modified version. I could rewrite this equation as P of x comma y times dx, okay, plus q of x comma y times dy is equal to 0. Now, if you keep looking at this equation, you kind of realize that, this looks awfully like the total differential of a function. So if you have some function f of xy, the total differential is defined as d of f, df is equal to del f over del x times dx plus del f over del y times dy. This is the official definition of total differential for a function of two variables. Now, these two things kind of look extremely similar, given that we make the assumption that this is nothing but del f over del x, and this is nothing but del f over del y. Now, from your knowledge of multivariate calculus, you kind of know that if you have a function f of x comma y and its partial derivatives del f over del x and then del f over del y and del square f del x del y and del square f del y del x, if all of these guys are continuous in some open interval or open region, okay, it could be an open circle or it could be an open rectangular region. If it is continuous in all of them, we can safely make the assumption that del square f del y del x is equal to del square f del x del y. Now please pay attention here that here the order in which you take the derivative that changes. Here you take the derivative of derivative of f with respect to x first, and then you take the derivative of the result with respect to y. On the other hand, in this one, you take the derivative of f with respect to y first and take the result, and then take the derivative of that thing with respect to x. So this is a conclusion that's going to be useful for us. Now let's go back to our original equation, and this is what our original equation is. Now look, if there exists a function, if there exists some function f of xy with the following properties here, partial derivatives being continuous in an open region, then we conclude this. Now we could use this result to ensure that, if we can somehow take the derivative of p, okay, so I'm going to take the derivative of p, partial derivative of p with respect to y, okay, and I'm going to take the partial derivative of q with respect to x. Then p is nothing but del f over del x. So I have del over del y. I'm going to take the derivative of p with respect to y, but p is del f over del x, right? And similarly, del over del x, okay, q. But q, according to our assumption, is del f over del y, right? Now, if you combine these two, what do you get? Del square f del y over del x, and from this one we get del square f del x over del x del y. oh, by the way, look, this is nothing but this, right? So these two must be equal. So this is very, very important for you to realize that. Now, this condition ensures the existence of such a function f of xy that would be the solution to this differential equation. Now, what does this mean in terms of our differential equation in this format? P of xy dx plus q of xy dy is equal to 0. So for this equation or this equation to have f of xy as a solution, it must be the case that del p over del y is equal to del q over del x. So this is the most important condition to ensure that we have a function, there is a function out there, f of xy, that would be a solution to this differential equation. Hence, our condition for the existence of a solution to this exact differential equation must be this: del p over del y is equal to del q over del x. So that is what we need to show. On a side note here, this function f in the world of physics is called a potential function. Just so you know, it's for reference I'm mentioning this. Now, this is basically what it entails to have a function that is going to be solution to this exact differential equation. Of course, you need to keep in mind this solution will be sort of in an indirect format. I hope that this discussion was helpful. Thank you very much.